Hmm. Okay, so what we're gonna do today is a few things. Now, if I compile, for example, lists, right? This actually doesn't work. I can create a constant integer and I can print it, and then I will not be able to add it to the list, which is quite unfortunate. So what we're gonna do is fix that. So let's just test it right now. What I need to do is comment out some of these inbuilt functions. Um, for the build folder, examples lists, and then that's our output Minecraft world. Okay, so there's a few problems we gotta fix before we go into the nice fun stuff, and that is this warning. The other warnings are fine. That's fine by me. What I'm gonna do is I'm actually going to get rid of them. But yeah, what I'm gonna do that is I'm gonna do that right now. So RBC CPP, no, it's now in parser. We're down to the very end. I can actually just comment this out. Okay. Then these warnings here. Unexpected token after variable usage. So it hits a bracket and it warns us. So case equals, if it's a parameter, break. If we hit a comma. Hmm. Yeah, that's a bug. So we gotta go in here and we gotta say, oh my god, I just spilled water all over my setup. Whoops. Okay, thank god it didn't hit anything. It didn't hit anything. Oh my god. Just about to have a brainwave to fix the problem. And I spill some water. Great. Okay, we'll let that dry. Anyway. So obviously here we should have a close bracket as well. And I don't even want to put a break here. I actually want to go down and warn. So only if we're a parameter can we escape that nonsense. And I'll also do that. Yeah. Should be good. So now when we're parsing a list, so list parse list. Okay. Yep. So this is parsing a list. Where is that error? Where is it? Cannot assign constant. So we're using type verify. Obviously case. Apparently. Is that in parse list? If I go to parse list. Do I type verify? No, but what I do is I go to var parse, and when I assign it, well, this is a list of integers, which should compile anyway. Nope. I'll fix that in a second. Yeah, we call it type verify here. Mm. So we go into type verify. Cannot assign variable value to variable of different type. So it's going here because we're using. Hmm? Oh yeah, switch value.index. So if it's a constant, register. But if it's a list, then we're gonna go into if the array count of the type is equal to 0. Okay, so I need to go to type parse. And obviously we need to specify that we're using a list of integers. So it should be this. That works. That works fine. So, problem is, doesn't match. But the error is quite stupid, so it happens if we're using a variable. Yeah. So we need to go back to var parse. And we say if what we've just parsed is a list, say if value, no, sorry, result dot index is equal to standard. Wait, how do I do that? We'll just do 4. Zero, 1, 2, 3, 4. Yeah, so if we're at a list, I want to go back to where we called the type. So we just got to make sure that if the variable type info, if it doesn't equal we can just do array count equals 0, then we can comp error, say syntax error, cannot assign list type, list instance to variable to a non-list typed variable. Okay, that should work. No? I think it'll work. All right, coming together. But that's what I'm gonna try and make today. Maybe it's just some generics. Hmm. Oh my goodness. So how do we make generics? It's a good fucking question. First of all, let's parse them. So we gotta switch current token type, and we'll do case. We'll do info, I guess. Case that will break. Case a less than sign, we need to parse function generics and go back. So go, can we do that? Go to type parse. No, we can't. Hmm. I guess I could do this with just a simple Boolean flag. So here's the type parse. And then we'll just say if as generics, we can just compile error, syntax error, unexpected token. So we need to do parse generics, generics parse. We'll do a shared pointer to function generics, RBC function generics, and we'll just say if generics. And what we can do here is generics is going to be equal to that. Okay. So let's go to our header file and create that. So keyword object type. Could be that one. Couldn't tell, you know. I don't think I use those anymore. I think it's just type define. Find references of this, please. Yeah, I never used. Okay. So it needs to be type define and current token dot info equals object keyword ID. There we go. Then is object only is true. Else if current token type, if the type of the current token is not a word, if it's not a word, then we will comp error, syntax error, unexpected generic name. Now down here, here, I will call advance, and I will actually get rid of this if. So we want to just make sure we're only doing a word here. Okay. Next we should advance. Yeah, advance. Okay, do you know what? We're actually going to put an advance up here, because that's going to skip past the comma. And if I go down to generics parse, we can actually get rid of this advance. So that should help us out a lot. Okay. Next thing is implementing generics everywhere. So obviously, let's say I made this function here, and I wanted to make LT array is list. I wanted to copy it, right? Well, I would need to do that in type parse. If we couldn't find the type function, the custom type, then we look for generics. You know what I'm gonna do is I'm gonna clean this up a little bit. Go to after type, I guess. Then after this, actually, let's go into generic parse for a second. Obviously, we can have this in a nested function, right? We can have it in a nested function with generics like so. So we'll just say if I'm gonna go through the function stack. Did I not copy that over, or is it in? It's in program. Sorry, program dot function stack. If parent function dot generics fine and auto reference parent generics is parent function generics. If parent generics entries find dot find current token repr, just rename that, save some processing time. Now let's go back to type parse. Okay, well, we got to think about something here for a second. What about the function call, right? So if I have L being a V and is equal to 432, right? Something's not going well here, right? Because we'd have to check that V does in fact equal the type of this. And of course, if we did V array again, what if V was an int array? Yeah, then wouldn't be so good. So what I might do is add some syntax so we could do something like that. Yeah. But imagine I had this, right? This would only work if v was an integer. Then I do append, and I call it with L. And I append the value S. Now t will be whatever v is, which we know it must be an integer, right? Imagine we just did this, right? Let's construct v, construct v, construct v. And v must be an object. That's why we have the object keyword, is you're allowed to construct it. Obviously this isn't gonna work. What we need to do is do you know what we need to do? Let's make a... Okay, this is looking disgusting. Can I please line all this up? Okay. Now what I want to add is I want to bring down this all the unordered maps so it looks a lot cleaner. So all the maps go down here. All the vectors can go down here. Shared pointers. I mean, the only thing initialized is context, so we can do anything we want. And then we can put the stacks like that. Now I want to make another unordered map of strings, which points to bool, and we'll say current generic types. Now every time we call parse generics, or generics parse, yeah, go down to that. And then we can also do program.current generic types. Well, for all the generics we find in here, Hmm. Let's just, insert all that. We know there's no duplicates. We can go into generics parse, and what we can do is, instead of going through all the parent functions, we can just do if program.current generic types dot find generic name is not equal to program.current generic types dot end. Then we can comp error, syntax error saying expected generic type name. So that works fine. When we call C bracket closed, when we get to a function that we're exiting, what I want to do first is if program.currentFunction. If it has generics, then we need to every generic in there. We need to do program.currentGenericTypes.erase generic dot first. So get rid of those generics. One thing I was going to talk about was the calling of a function with explicit generics, which we'll have to figure out as well. So if I did this, that's how I would call it. So realistically, all we need to do here is, on the function call, everything is T, so we can just make sure we know it's generic, right? And compare types is normal, right? Compare types is normal. When we call a function call, this will already be done perfectly for us. We don't need to do anything with the types. Right? Well, actually, no, because what if we wanted to do... What if I wanted to do const x, which extends from t, is value plus 2? Well, first of all, if it's an object, that's going to fail because we can't add objects, right? Else, we need to wait for the function call to generate this entire function. Okay, so we do that, right? So we just wait until we call it, take the type, stick it in for there, make sure the type verifies, and parse with, you know, okay, let's say, get rid of the object keyword here, and we say, okay, int array is list. So then, yeah, that works. Int array is int array. And then int, x's int is int plus 2. So that all works, right? But imagine if you did string. Whoa, no, no, no. Not gonna work. So who did you And I also want to make a flag called... Well, if it isn't parsed, then generics is true. So we don't need to do that. Okay, this is just called a range. And it'll be a range of size t. Okay. What we're gonna do here is we're going to because we have generics, we need to parse the function every time we call it with a different type. So we skip over the body. And parse it if it exists when we get the type info we need. So now what I need to do is go into bytecode, go into function generics. Now we have variations of an RBC function, right? So I'm going to make a unordered map of redscript type info. Does that exist? Type info? Yeah. And a shared pointer to an RBC function, which I will need to forward declare. And I will call this variations. Okay. Time to ask ChatGPT, how would I make this code compile? Because I don't think it will. So I need to make the Okay, so what I'm going to do is I'm actually going to create a new file called types, or I'm going to call it type info. And I'm going to go into lang and find struct type info. Is it here? Yeah, look, I can take this entire thing and I can just include type info HPP, which will give that to us. We can include pragma once, include string, include C types, type C standard int, sorry. Include a vector. So now I can go back into RBC CP HPP, get rid of the forward declaration and just include type info. This is defined in constants. So here we need to include constants. Next thing I need to do is make the namespace standard and template struct hash of rs type info. Let me see if ChatGPT, how would I hash it? For example, T array is not the same as T. What in God's green earth is what? Okay, wait. Inline bool. So, you know what I'm going to do is I'm actually just going to trust ChatGPT here. And this is a really bad idea. Like a really, really bad idea. I just hope it hashes, you know. Okay, so now that that works, wink wink, nudge nudge, we need to skip over everything. So parser, go back to parser. So we need to do while advance and current token type does not equal to, wait, no, we'll just do while advance. And the curly bracket count, b count is equal to program.current scope. Do you know what I'm gonna do? I'm gonna do bracket count is equal to 1, sorry. If current token type is token type C bracket closed, BC decreases. And we'll say while advance and BC greater than 0. And then we'll say if it might be a problem, like, for example, if I put a bracket in here, the parser just shits itself. Here we have curly bracket is 1. Yeah, see, if you have an unmatched bracket, it'll get to the end and say, well, what I'm going to do is I'm going to token is current token. Okay, and then we'll say if we can't advance any further, if we can't peek the next token, no, if we can't resync, then we need to compile error. Yo, man, how's it going? This is a banger music. I don't care what you're on about. And just for... So what I'm doing right now, Shadman, is because I want to make the standard library for this, I need to make generics, and I'm kind of trying not to kill myself right now. But let me know what you think about the syntax, and let me know what you think about my approach, right? Give me 2 seconds. Nah, generics are powerful. What I'm doing, right, is I'm basically... Okay, wait, let me write this. I'm just going to say current token is equal to at. So we go back to where we were, and then we throw the error. So yeah, unmatched closing brackets. So what I'm doing is obviously I'll parse the generics. Mate, look, what I'm doing is I'll parse the generics, and as you can see, there's a keyword object. So if you pass in an object generic, then you're allowed to do, you know, v, like if I create, you're allowed to instantiate a v and then do a .x, for example. I haven't like implemented any of that yet, so there's no object instantiation or accessing. But that will only accept custom types, custom objects, right? But if it's just a type, then it can accept, you know, ints, floats, int arrays, 3-dimensional int arrays, stuff like that. And as you can see here, this function definition, I'm just writing some random stuff, right? What we're going to do is we're going to parse the generic, and we're going to add it to a map of generics that we're in. So currently it's going to be v, which is an object, and t, which isn't an object, right? And then we're going to parse the parameters as normal. And then we're going to skip past the entire body, okay? Skip past it. We're not going to parse any of it. What we are going to do is wait until we call append with a certain type, right? And then when we call it with the type, we will go back, stick in the type for t, yeah, parse it, and then throw errors if it doesn't work. So the reason I'm doing that is because, and I think some languages do it that way, you know the way you can't get type checking when you do certain generic functions, they don't know what they're doing, because operators like plus only work here for ints, right? And remember, I'm not, like, Minecraft is only going to let me plus ints. So this will throw an error if value isn't an integer. So what I gotta do is just skip past the entire body, forget about it, and then once we call with an append of int, then we parse with int, right? Then we'll create the function, we'll mangle the name, we'll stick it all together. And again, if you call append int again, it'll just call the same one, right? But what if I wanted to append to an int... sorry. That's... What if I wanted to append to an integer array? So 2 arrays, right? Then it will create the entire function again, a new function, and parse again. To be able to write a hash table in any language in 15 minutes. What do you mean? Would you be able to write a hash table in any language in 15 minutes? Is this a challenge? It's a question. I don't think so. Unfortunately, I've never really dabbled in the intricacies of hash tables or maps. I am a noob when it comes to that. I will admit it. I do, like, I know how they work, but I don't know how to implement it properly, unfortunately. You gotta be so mean, bro. Anyway, I think this approach is good, right? So it'll create a function for every type we use in our program. Yeah, I know what you... Don't worry. I'm guilt tripping you. So, like, obviously this would fail, right? What do I need generics for? Honestly, nothing. No, okay. I need generics because it's strongly typed, and I was thinking to myself, okay, what if I wanted to make a function called append that appends an item to a list, right? Well, if I wanted to make it inbuilt, how would I write it? It's strong typed, right? Okay, so how would I write a void method append that takes in a list, and what the hell do I call it? What type? I used to have something called any, but that's gone now. Okay, any is gone now. You can't pass any in. It's strictly typed. So if it's strictly typed, then I need to use generics, and I need to just, you know, just do that and that, and then make a value. And then I can handle the implementation fine in C++ if I wanted to. So I'll add the decorator CPP, and then no compilation time is wasted, you know. Strong type system means you can't implicitly cast. It doesn't mean that you get rid of any. Any wouldn't be able to exist in a weak type system too. Well, I'm choosing the wrong words, but every variable must have an explicit type. And the any keyword fucks it up, like, really bad. This will work fine, though. This will work fine.
Everything changes.
No, but my language won't have that. My language won't have that. Again, there's no casting. There's Boolean casting for if statements, like implicit casting, but there's no casting yet. There will be object casting, but casting between floats and integers and other stuff like that just can't happen in Minecraft, or as long as per my knowledge. So this is as complex as the templates will get, you know. And the reason why I'm adding it is objects. You can literally, you can simulate inheritance, I guess, with kind of stuff like this. And you can simulate extra external functionality. To read about the Minecraft language. Yeah, if you go to MCWiki, just Google MCWiki commands, you can go through the whole list of commands. All it supports, like if you go to the scoreboard command, it supports integer arithmetic. And then if you want to do floating point arithmetic, you have to represent your floats as integers, add them, and then represent them back into floats. Very bad. Very, very bad. So I might have to... I haven't implemented floats yet because I'm a bit scared. Anyway, let's get back to what I was doing. So... So scoreboard lets you do a few things. Scoreboard lets you, let me show you. If I have a player called TBCM and I want to store some scoreboard value, I would need to, first of all, create an objective. And the objective is the name of that value. So let's say points, right? So I'm pseudocode here, but we can do create points, create objective points, and then for any player in the entire game, we can just do, okay, set TBCM points to 4. And then I could set Shad's point to 10. And then what I can do with that is I can do scoreboard operation plus equals, and I can do TBCM points and Shad points. And then the result is stored in my points. So now if I print TBCM points, I will get 14. So I can do maths. This works with mod, it works with XOR, they have all that supported, right? So I have 14. So what I can do, what about floats versus ints? Yeah, there's no floats supported here. Scoreboard only accepts integers. So the way I have to make it is I need to contact some guy who made something 10 years ago that converts integers to floats to integer representation. Now remember, there won't be any performance shitholes. So this 10.1 would just become something like some mangled number. And we add that to a 4.2, which would become a mangled number. And then when we want to print the float, that's when we want to convert it back. Otherwise, we never need to do anything with it. And then, just bear with me here. How does RedScript work? Well, all it does is it uses someone called the underscore CPU for all operations. Replace this points with register 0. This points with register 1. This points with register 0, register 1, and print register 0. Now can you see how a language could work here? There. So now I've just added 2 numbers and the compiler has done that for me. Why can't you use what is called fixed points? You store one number which is on the left of the decimal dot and another that's the fraction. Yeah, I think that's what he does. I think that, yeah, he stores the fraction. But the fraction in integer representation is crazy, isn't it? It's like, it's impossible to decipher. And remember, like, I don't care how I store it, as long as the maths adds up. I'm pretty sure. I'll show you the video if you want to watch it. Let me find the video for you. Don't store the literal bits under the hood. You just store the base 10 representation. Give me an example then. 12.3 would be stored as 2 integers in 2 separate locations, 12 and 34. Alternatively, store them in one integer, but make it so that you multiply it by a fixed number. Yeah. Okay, let's do a little watch party, all right? Because I know that method you're using. Let's go watch this guy's video, right? 5 years ago. Utility data pack, configurable base floating point arithmetic.
Welcome back. In this video, I'll be showcasing an array math utility. This allows you to do math operations with arrays of numbers with a specific formatting. The arrays are mixed base, or you can configure the base value. Currently, mixed base is not start array math in, and we have a very specific format here. Let me actually open up this here.
So they're using decimals. Look, this is way too many maths. Way too much maths. I think, like, there's too much being stored. Remember, we're also storing the keys of these as well. I don't know. Yeah, again, it's too much, right? I use this guy. Or I watch this guy. Very interesting. Very interesting approach. I know, I agree. Base, yeah, I don't need to... I should... I don't know why I haven't enabled my ad blocker, but... It, like, gives me warnings on some websites.
And if you look over here at the result, and then we have the action.
So he represents, obviously this is how floats are stored. You have the sign, the exponent, significand. Those are all the bits. And then
that leaves the exponent stored over here. You'll have to subtract 127, and if you do that, this number here is 129. So you'll get the exponent is 2. So to get a 5, you'll take the decimal place from here. The decimal place always starts to the right of the invisible 1, and you'll move it 1, 2, and then you'll get 5.0 in binary, and that's how floating point numbers work. I've implemented this in Minecraft Scoreboard by ignoring the display. They are displayed as integers, and just using the bits directly underneath them. Right here I have a function to convert an integer to a float. So I will convert a 3 to floating point, and you'll see in the sidebar that is what 3 looks like as a floating point number represented as a decimal integer in the scoreboard.
It's probably faster,
a function that converts.
Yeah, well, remember, like, everything is super limited in Minecraft, so this might be the best.
And for this one, I'm just taking the value that's currently in output and turning it into an integer. So if I click this, you'll see we get 3 back in the scoreboard. And if that number had any decimals, then it would have been lost because the scoreboard can only display integer values, so it would cut off the decimal from that number.
But this uses multiple entries in the scoreboard, whereas a fixed point would be simply an integer. No, it doesn't use multiple entries, I don't think. What's the max integer? Good question. God, I have so many tabs open. Jesus Christ. Max integer scoreboard Minecraft. Max integer, come on, tell me. I think it's as big as an integer can be. I think it's 2 to the 32 or whatever. I don't know what it is. Scoreboard objectives. Here. Wait, tests if target scores are within minimum and maximum. Oh, Bedrock Edition only. Damn it. No, I got it. That's the lowest and highest. 2 billion. 2 billion, yeah, so 2 to the 32, I think. No, 2 to the 16. 2 to the 24. Am I going insane? 32-bit signed integers. Signed integer. Yeah, so that's as big as the numbers are going to get. I don't think it is either, because people will be using floats more than ints. So if I just make floats good, like remember maths is kind of what we're doing here. A lot of math stuff. And people are going to be using the integers if they're not going to go that big. Listen, right? You know your stuff with floats. I don't. If you want to go into the Discord and write a little piece on forums, like what Sebastian did a few weeks ago, he would, you know, just give suggestions on how to implement it. Floats go up to like 9 billion. Jesus Christ. Wow. Yeah, like, you know your stuff, and the whole reason I started streaming was to get people like you or other people just to help me out, because I can't do this on my own. There's no way. Well, they go infinitely, but to 9 billion something, they don't lose precision. I'm too big of a noob. Thanks, man. Don't listen to people telling you to use... Cheers, mate. I'm a noob, but I learn fast, and I learn what I want to learn. I'm just not in... I'm assuming you learned how to use the floats and use, like, you know, see how they're represented in binary and everything through college, which I'm still doing, so cut me some slack, would you? Okay, so... It'll just wrap back around, probably. And I'll give a compiler warning, like... People will know the risks when they use it. Store the multiplier with it. Ooh. Okay, I haven't gotten around to this. I'm working on generics. Let's get this done. Let's get this done. So, currently I've skipped over the function. And if a function is... Listen, I think you are working on the wrong thing. No. What I'm doing may not be the right thing to do now in your eyes, but it definitely needs to be done. So I'm gonna do it regardless. Why do you do this when you don't even have the basics and no tests and shit? I don't know how to explain it to you, alright? Like... This is the basics. Don't even have an application for this. What do you mean application? This is the basics. The basics of any language is any part of the language. Yes, I know. But what... Okay, alright, look. I've spent almost half a year on researching on how to do stuff, okay? Do you want to know how hard it is to plus a string and an integer together using Minecraft? This shit is incredibly difficult. And just remember, right? String integer is the same as integer string. And Minecraft doesn't work that way. There's a lot of problems to do with that. So I would have to do hundreds of manual MC function implementations for, and I will be doing this, for everything. So it's not about the parser, it's not about everything, it's actually quite literally about my inbuilt library. Is there really no language like this yet? No, there isn't. What's the mainstream way of going about programming an MC? You use the commands. You just write what this compiles to, you just write in it. That's it. And people are really, really good at it. So I probably will get some backlash for making this. I don't think so though. So writing in MC functions is... I will have to make 100 of those, I think, before the language can do a lot of adding together. Yeah? Like, people, when they pick this up, Shad, are gonna have to... Show the lang for MC and... bro, this is patented, don't you worry. People are going to... You know... expect that if I add an int and a float, it should be fine. But that's just so impossible to do right now with my state of knowledge and how numbers work in Minecraft and how I can do it in the most efficient manner, right? So what I'm doing here is I'm implementing features. What I've been doing for the past few weeks is cleaning up, implementing features, and implementing features that don't impact the performance. Because I'm doing these features, right? So generics, lists and objects, just adding those. So normal programs can be written. And then maths comes next. But it won't be released without maths. Maths will still be done. But it's not worthless because it helps me write my inbuilt library. You don't see it yet. It's necessary for me to write the inbuilt library. No, I know the user can, but I can't. I need to write a lot of... You don't understand the sheer scope. So I have to make inbuilt functions for getting a player's name, getting a player's everything. I need to write the entire object for everything a player contains, everything blocks in the world contain, how to manipulate blocks. These templates help massively. Start writing your own generics and library. Use C++ and just a transpiler to convert a C++ binary to MC. That's just more boring. That's more difficult as well. Do you know how many assembly instructions there are? Kind of reinventing the wheel. A transpiler? Mate, that's like trying to put the square in the circle hole. There are if you compile on native Arch. I don't like that at all. That is disgusting. Like learning how C++ compiles, that's even more difficult than this. If I can't read C++ standard library as it is, I don't think I'm going to be able to understand how the language compiles. They have veterans, people who went to like the Vietnam War coding on that shit right now. I think I'll let them do the tough bit. Okay. I'm not going to let you discourage me, Shad, because I'm just adding features, okay? There's no release date. These features are just nice to have. Sure, you might not use them, but I definitely need to use them if I'm making the standard library, okay? If you don't use Arch as native, then the compatibility instruction set is much smaller. Can I add a float to an int in your lang? No, you can only add integers because floats haven't been implemented. I'm waiting, like every day I'm researching. Why do I need generics? You're actually pissing me off. I'm not gonna, it's coming. I promise you. I'm just adding features. Is it illegal to add features? Maybe, look, maybe a big shocker. I want to not do floats right now because they're very complicated and I want to do it right because I rushed my parser and now I have you telling me I didn't do it right. I don't want to rush those things. What functions are there? Do you just crunch numbers or can I call some command with your lang? Yeah, you can call commands. So the reason the inbuilt function, look at this is the lang redscript file, right? Right now you can print things to people. You can kill people, right? But that's about it because every single one of these I need to write in C++, which is quite annoying. And this is the one thing I'm not very proud of. Like here, look. Message basically just says, okay, we have a selector as the first parameter. Make sure it's a selector. And then make a command. So these are transpilers, these functions. They don't actually mean a Minecraft command, this message command takes in your parameters at compile time and then converts it to a tellraw command, which tellraw is used to send data from storage to the user's chat box, right? So that's the tellraw, that's a converter. So I have to write that in the compiler itself. But with generics, I don't need to, you know, they can help with a few functions, but there's like 100 Minecraft commands. So I need to come up with a better way of doing this, I think. Maybe not, maybe not. So what specifically are generics going to help you with? Good question. I had a brainwave earlier. Let me find that brainwave again. Yeah, I told you it was about the passing in of any type to a C++ defined function, for example. So message right here, I could let it take in whatever it wants, because message can actually take in an object, a list, a number, and print it to the user, can't it? So this message doesn't have to be a string, it could just be a generic type. So it can just be like that, and then in the C++ implementation, I don't have to worry about the compiler screaming that, oh my god, I have an any keyword in here, and the any keyword users can use, you know what I mean? Just use generics, and because it's C++ defined, there's no body of the generics, therefore nothing has changed, but it's a nice and defined way of looking at messaging whatever you want to the user, right? But this is saying it must be a selector because we can't just pass in a type here. So how is it going to look in C++? What do you mean, how's it going to look in C++? Like the body of message? You're going to have a function for each type that you pass to it? No. Remember, everything is a variant, a standard variant, which means the index corresponds to what's passed in. So here, if the user passes in a constant, it's 0. A register reference is 1. A register reference is when I do something like message at p1 plus 2. The compiler interprets that. Remember the register example I gave you earlier? Then it will store that in a register, and then it will get 1 plus 2 and pass it in as a register to the parameter, right? But the compiler is smart, so it actually just gets turned into 3 as a constant, so we don't need to worry. But if it was 1 plus x, for example, then you'd have to pass in a register. But if you pass a variable to it, then at compile time, you can't convert it. So you will have to write some conversion shit in Minecraft. Exactly, yeah. That's what these functions are. Because the user should be able to say, okay, if I go and print at p variable plus 2, or variable here, they expect that to work. So the reason there's this decorator here is so that it is working. It's programmed here and it works. Why have generics at all? I think readability in the inbuilt file, but I will get back to you as to why it's needed. So why not make it just one message without generics and just use a cast or function like string or int? Yeah, because casting in Minecraft does not work. Just doesn't work. And it takes an extra command anyway to cast. Why not make it one message without generics? No, but remember, there's no difference. Like T and then T here, a strict T, for example. There's no difference to the, like, I'll implement it so you don't have to specify string. Message a string. I'll make it so you can just type it in whatever you want, right? And the type will be deduced through that, right? So it's not delaying the problem. I know you're not a fan of generics, but it's quite powerful in languages that really have, like, RedScript is a language that does everything badly, okay? Because that's what Minecraft is. It's not built for a language to run inside it. So the more non-runtime features that I implement, the better people can write their code. Do you not agree? Completely useless addition if you can just cast the expected type by yourself with a standard library function. You were just hiding the cast call in C++. I have plans to implement casting. But then I would also have to implement implicit casting. And implicit casting in Minecraft is extremely costly. If I want to cast a float to an integer, we know how costly that is, right? Implicit casting then therefore shouldn't be implemented. And then everywhere people want to print to the user, they have to write a giant cast. They have to write a message at p string x. They have to do that over and over and over and over and over. That's why generics exist. This is ugly. Implicit casting will not be in my language because people should know its implications. That's basically it. I don't agree because you can barely write a parser and you want to do generics now. I think it's just going to fail or it won't. And then this is just going to eat up a couple of weeks of your time for nothing. I can finish generics today. Like I said, like if we didn't yap so much, and I can write a parser. I can, I promise you, it's halfway done. All I have to do, skip past it, then parse, snip it in the type, and then mangle the name and connect it. Name mangling's already in the compiler. I'm gonna show this to you. Just watch. Just watch. Look, we gotta count down, okay? I gotta count down. I'm a bit, I don't know, today has been a bit weird. I'm a bit heated. I can write a parser, just not the right way, I guess. But I hate when programmers say that to each other. There's always a better way to do something. It doesn't mean my way is wrong. I think generics are so easy, but floats are so scary. Yep. That's just Minecraft. Nothing else I can do. So what I'm going to do here is... recursive descent, which is more performant, but it's unreadable. It's basically just an optimization. And I find it funny how you're saying you're going to waste weeks just working on generics. If I change to a recursive descent, I'm going to waste weeks writing a recursive descent. No, it doesn't make life easier. It makes life easier 3 weeks from now. Because I need to refactor my entire project since the 4th commit or something. Won't be a waste because it will create a complete foundation for everything in the future. But that's the thing. Everything in the future, the only problems I have, Shad, is floats, which is Minecraft itself. The problems with my language is in my language. It's what it's compiling to. Imagine you're right now working at the speed of x5 because of this shit code, and if you switch to red, you would work at the speed of 0. It's not about speed. It's not about speed. It's not about... In 2 weeks, this language will be ready. In 2 weeks. It's not about speed. I don't need a lot of features, and I know I'm writing generics, but maybe I can remove it later, and this is why I'm writing it in dev branch, okay? It's just an idea, and it helps me write a lot of inbuilt functions that could work with multiple types, right? My speed is fine because my parser does enough, okay? I know you're thinking, oh, but recursive descent lets you write complex expressions and it understands it better. And I'm like, I don't want complex expressions. It's literally in my language defined that if I do y is an integer is something plus 4, this does not compile. Because I have explicitly said you can't have function calls in expressions. Okay? That's just, everything needs to be written properly in this. And because of that, my language isn't so complicated after all. I mean, it really is just quite simple. It's about making the code literally readable and extensible. Look, I'll admit defeat on readable. If mine isn't readable, it isn't readable. But that doesn't mean it doesn't work. And it doesn't mean I don't understand it. And it doesn't mean I work very slow. Some people would say, oh, you are working slow. But I don't think so. I think I'm working slow because we're yapping. Okay, that's enough. That's enough. I don't run into bugs every day. I don't. I know the streams you've joined into, I have had a bug which I couldn't solve. But it was just because of my missing a line or so. Like, I didn't reset at to 0, and then it tried to access a vector outside of its range. That's my fault. That's not because of the parser's fault. Like, I just couldn't find the error. Sometimes errors just take a while. Can't blame us on that one. We're programmers, aren't we? Let's just agree to disagree, okay, Shad? I agree your way is better, but I also agree that my way that works. So if it works, it works. So what I'm going to do now is we've skipped over it, and I'm going to go to call parse. Wait, hold on. If we had a line end, yeah, so we need to go to so the current token is going to be a bracket close. So at the end of this, we need to go to decrement scope. Is this like a proof of concept since it's so slow, or what's the plan? What do you mean? The language is no, it's not a proof of concept. It's about 50% done, I'd say. Generics will be the last feature I implement before I have to just write the giant standard library, including operations, you know, custom operations, floats and integers, like you said. And it's done. It's done. The only thing I need to write after this is really, really helpful. Objects. So I'm not sure if I showed you, but you can define objects as, let's say I had an object player, right? At the end of the day, this object, this does compile currently in the current version of Redscript, but we can't use it. So I can't instantiate it, right? Well, what we know about this is it actually converts into JSON. So the player is just a JSON. So there's no constructors, there's no nothing. So for example, let's do a name, which is a string, and we'll do a health, which is a float, technically a double, but again, I'll add the double type if it sees fit. And we'll say UUID, and we'll call it a UUID type, right? Now, let's take a step back. How do we write a constructor for this? Do we do some boilerplate like this, name, health, UUID, and instantiate? No. We can make the best of two worlds. We can use the keywords required, optional, and separate. These three keywords help us to write the constructor and make our program extremely performant. Let me explain. Let's say the name is required. Every time we make a player, we need the name. Every time we need the player, we don't really need the health. So what are we thinking? Maybe optional is the default, but I'll write it for you anyway. I think it's optional, okay? And I'll get to why we have the keyword optional, and UUID is definitely required. Now, if I was to go into my program and I was to say x, which is a player, is equal to some getPlayerInBuilt function, right? You do not want to know how many fields. If I don't do this, right? Imagine I don't do this, right? If I had in my lang file a player, this player has like 300 fields. The object data, the data object on a player has 300 fields. If you wanted to just get the player that you're working with, sure, that's fine. One line of code is literally going to take a comparison that takes ages. Not obviously ages as in like 2 seconds, but it's hefty, right? So what you can do is, okay, imagine that returns an object. We can call this minimal player. And we can actually perform object casting on that player. And what the compiler will deduce this as is we need to get this object, and this object will be defined, right? So the object player will have like, which is what get player returns, will return like 300 fields. Okay? It will strip, it will take name, it makes sure that it has a name. If it doesn't have a name, the compiler throws an error. If it doesn't have a health, that's okay, right? Health will just be set to nothing. And, or obviously you can define it as 0. And then UUID has to be in the player. So obviously that's how we write constructors. So if I wanted to create a player, a minimal player, right? I could just do minimal player. I don't know about the syntax. I think I'll use the new keyword. I like that a lot. Minimal player. And I pass in shad. And then some health. Obviously, it will be in the order that you do it in. But health doesn't apply to the constructor. As long as you create all required, that's okay. So there might be a problem with ordering, which I actually haven't figured out, so I'll blame that on me. So we have shad, we have some UUID here, and then I could optionally add some health, right? So 20.0. So that's how we can create players, and that's how we can save performance, because imagine the giant copying of 300 fields. Just imagine. Crazy, crazy. So yeah, that's objects in a nutshell. And that's the feature that after generics, I will add. Okay, generics only work on functions. Objects will not have functions, except for something to help increase performance again, like, I don't know, underscore compare. Right? And this will just be, it'll take in name and UUID. So for two minimal players to be the same minimal player, the name and the UUID would have to be the same. We don't care about the health. We don't care about how many chocolate bars they've eaten or something like that. As long as the name and the UUID are the same, they are equal. So the compiler can help optimize even further. Does that make sense? After this is done and the standard library is written, the whole language is finished. I can do that all in 2 weeks. That's just the plans I have. Half-half, but I get it, I guess. The docs will come. I have it on a separate machine. You can't read, it's top secret. But everything's about performance here. And anything that can be used at compile time to help write a program, I will go for straight away. Okay? Straight away. So, let's get back to finishing this so I can go outside and talk to women. We both know that's not happening. Okay. So, on call parse, we can call with the type. So it's actually really simple. I know you don't like my parser, but let me go into call parse. Oh, you may go? You're gonna go? Alright, man. Thanks for tuning in. I'll talk to you soon. So I'm going to go into call parse, and we call it the name. And then after the name, this advanced keyword, after the advance, we're gonna say if current token info, so obviously if it's a open less than sign, we can call generics parse, and we'll have to advance after that. And we can do the generics we've parsed will be a standard shared pointer to an RBC generics function generics. Okay, so now that we have the generics of the function, we can start to do some stuff here, which I gotta figure out. So when we call this function, we know we have, if I go to the function that we found, function dot parsing range, I know the range of the body of the function. So what I'm going to do is I'm going to get this generic function and I'm going to copy it, but change every reference of t to be the type that we want. Okay? Simple as. And then we just parse as normal. So I'm going to make a function probably called instantiate generic function. And we're going to pass in the generics and the function. And this will return a new function which is compiled, right? So we have this function now, and let's go make that function. So now that we have it, we can actually just set function to be compiled function. It's as simple as that. So instantiate generic function. Let's go into the parser. Sorry. So now down here, I'm going to do a shared pointer, RBC function, instantiate generic function. We're going to take in a RBC function generics. Just do const generics, and then we will take in the function. I love this song. Okay. So, to instantiate the generic function, okay, we actually shouldn't be passing in generics. We should be passing in a vector of RBC type info, and we'll make a reference. Cheers, mate. So we need to make in a vector of types, and we'll just call that types. Let's change the function signature. Hi, how you doing, Adam? How is things? I just got flamed by some other guy for implementing generic. he's funny, but he doesn't like the way I implemented my parser. So apparently there's some sort of parser called a recursive descent parser, which is like low-key, I don't know how to make it. I have absolutely no idea. And it's a lot more optimal for making languages. And, you know, he's seen it in college. We haven't seen it yet. We'll see in a year or two. But my parser will just check word by word by word, by keyword by keyword. His doesn't. So it's better. And he keeps memeing it. And now that I'm adding generics, he thinks it's useless. But I think it's cool to add because in my language, everything that's compiled is really expensive. Everything that runs at runtime is really expensive. So any compiled away functionality is really useful, I think. Anyway, that's just me. I changed my errors. They look like this now. I think they look quite nice. A little bit of syntax highlighting there as well. What I'm doing now, nifty. Yeah, the colors might need a bit of work. I think I might be able to show you. There. No, it's in the Discord if you check actually. But what I'm working on now is obviously, you know generics, right? Have you worked with generics in Java or any other language? No? Generics are like types that don't have a type until they're given a type. So if I create a function with a type called t, I can call it whatever I want. 1 second. Hello. Hello. Sorry, I'm back. So yeah, if you fill in, they're called something else weird. They're probably called templates. Generics and templates, they're the same thing. But what I'm going to do to implement templates is I parse everything. Then I just find where the function body is, if it exists. Sometimes it doesn't need to exist. And then I just skip over it. And then if I call a function with a type and it is a generic function, I can just snip it in that type, put int here, and int here, and then parse as normal and create a copy of this function for just that type. And if it fails, it fails, but if it can compile, that's grand, fine. So obviously, unfortunately, there will be like, if I call append float, there will be 2 functions here. But if the function is inbuilt, i.e. handled by my compiler, so if append would just convert into Minecraft commands, generics are quite powerful because they let you pass in any type, right? So, you know, contrary to Shadman's belief, I think they're useful for me in the inbuilt library. So yeah, if you define a generic function yourself and call it with int, you'll make an int version of it. If you call it with float, you'll make a float version of it. And if they both compile, grand, you can call each of them. But I just got to make that. So what I'm doing now is the instantiate generic function, which takes in the types that we've given. I need to go down here and actually, when we call it, I need to parse all these types, right? So I have a function called type parse. Wow, look at the description I have for it. Parse is a type. Cheers, mate. So this will return rs type info. But what I'm going to do is I'm actually going to make a type info vector, which is just a list. And I will do while we can advance and current token does not equal to current token the info doesn't equal to the end of the generics, then we can call types.pushback type parse. So that should work, I think, I hope. Now that we have the types, we can just pass them in to the function. And this is still screaming errors because why? It's supposed to be constant. So now what we're going to do is now that we've called the function with its body, what we need to do is first of all, go to the function and copy it, right? So let's make another bytecode function, copied function, and we're going to copy it. So we're going to make shared to an RBC function. And we're going to pass in dereference a function, so that's just going to cause a copy to occur. Oh yeah, that doesn't work. Sorry, what did I call it? Function. Now, with this copied function, I'm going to go through its parameters. So in copied function, local variables. Wait, is there a get parameter? I can get end parameter. I don't actually have functionality for getting the parameters of a function because they're also included as the variables of a function. So I'll have to go through its local variables. Get parameter by name. Can I go to, what is it? 1 second. Okay, unfortunately, I will have to go, but I will start this up when I come back. Anyway, I'll see you guys soon. Thank you. See you later.